Hello everyone, this is Mr. Underkoffler. Today we're looking at the guided notes called Problem Solving with Prisms. And this is going to start with some basic questions that you should ask yourself when solving problems. What am I given? What am I asked to find? What can I then use to solve? And then finally, once I'm done with my work, does my answer make sense? We've talked about those type of questions before. They are essential to solving problems. Now, with 3D figures such as prisms, the problems are going to deal with either with volume or they're going to deal with surface area. So quick review. What's the difference between the two? How do I know if the word problem needs me to get volume or if it needs me to get surface area? Well, volume is cubic units. You will see a little 3 in the corner of the unit of measure if we're talking about the volume. But surface area is square units, where you put a little 2 in the corner of the unit of measure. So pay attention to the words today. Some problems will talk about cubic feet or cubic inches. Other problems might talk about square feet or square inches. That will help you to know if it's volume or surface area. But another thing that can help you is to pay attention to what the story is described in the word problem. If we're talking about filling up a 3D figure space with water or sand or packaging material or anything like that that fills up the inside of the shape, then that would be volume. But if we are instead talking about covering the sides of the 3D shape with things like wrapping paper or paint or some other things like that, then that would be surface area, not volume. All right, let's take a look at problem number 1 together. Lee has a candle that has dimensions shown in the diagram below and will mail it in a rectangular box that is 4.2 inches long, 5.8 inches wide, and 7.6 inches tall. Part A, find the volume of empty space in the box after the candle is inside. And then we'll get to part B when we're done with part A. Okay, so what are we given? Well, we're given 2 different shapes. Did you catch this? We are talking about a rectangular box, which is a rectangular prism, because we're talking 3 dimensions here, length, width, and height. But we're also given a candle. And the candle was shown in the diagram below. So it is, a triangular prism. Did you see triangle on the top, triangle at the bottom, are parallel to each other and congruent to each other. So this is a triangular prism. So we got 2 shapes involved. Now, what am I asked to find? I am asked to find the volume, so not surface area, but the volume of empty space in the box after the candle is placed inside. Well, how do I get that? I'll give you a hint. The candle is going in the rectangular prism box. So we're going to need to get the volume of the rectangular prism, and we're going to need to get the volume of the candle, which is a triangular prism, and then we will eventually subtract. And that will give us the volume of empty space. And spoiler alert for part B, we're going to fill that empty space with packaging material. Think about this in real life. When you get something shipped to you by Amazon or some other online website, and it comes to you, it often has packaging material separating the box from the item inside so the item inside doesn't get bounced around and damaged. Okay, so what can I use to solve? Well, we're going to need to know the volume formula of the rectangular prism, and we're eventually going to need the volume formula of the triangular prism. And remember, a triangular prism is a type of polygonal prism. That's where I got this volume formula from the polygonal prism's volume formula. All right, let's go ahead and start with the box. We do not have a picture of it, but we see the length, the width, and the height. So this is pretty simple substitution. Go ahead and write this down with me. Length times width times height, 4.2 times 5.8 times 7.6. Use your calculator, and that should give you a volume for the rectangular box of 185.136. Do not round that. In fact, don't ever round something when you're in the middle of your work still, because that would be bad. Okay, from here we can finally get the volume of the candle, which is a triangular prism, as I mentioned before. The triangle at the top is parallel congruent to the triangle at the bottom. And that's a good thing to recognize, because to get capital B is the area of the base. And I've taught you before that a really helpful thing to do before you get capital B is to draw a quick sketch of the base. So I'm going to do that right now, and you should do it with me. Draw a quick sketch of this triangle. And why am I measuring the 3.4 and the 2.6? Well, because to get area of the base, which is capital B, not lowercase b, capital B, I need to use the area formula of the triangle. So, from your formula sheet, area of a triangle, 1/2 times lowercase b times lowercase h. And the way that we recognize lowercase b and lowercase h is that they are the measurements that meet at a right angle. The height is normally the dashed line, so here's our height, 2.6, and the base would be the line segment that touches that height at the right angle. So let's go ahead and substitute in these numbers. 3.4, 2.6, going in for lowercase b and lowercase h. Since these were decimals, I went ahead and made the 1/2 become a decimal. If you don't want to make that a decimal 0.5, you don't have to. You can keep it 1/2. Calculator time. This is going to give us, I hope you're doing it with me, 4.42. Now that's just the area of the base. That's going to replace capital B in the volume formula. And as I've taught you before, the H in the volume formula is not the same thing as the H in the area formula. They're different heights. This one over here on the area formula was the height of the triangle, which was the dashed line. But here on the volume formula, we're talking about the three-dimensional figure's height. And that would be the line segment that goes between the two bases, the two triangles. So that height of the prism is 5.5 inches. Let's go ahead and write that down. All right, calculator time once again. Multiply, you should get 24.31. So let's recap. I found the volume of the box. I just now found the volume of the candle. Remember, I had to get the area of the base first, then I had to identify the height. Boom, got the volume of the candle. To get the volume of the empty space, I have to subtract those two volumes. And that will leave me with what's empty inside. So let's go ahead and write this down. Volume of the box minus volume of the candle. Get ready to use your calculator. This is going to give you 160.826. And now I can finally make sure I put the unit of measure. Oh, and I messed up. Oh, Mr. Underkoffler, volume should be cubic inches. Why did you not proofread this ahead of time? My apologies. Make sure that volume is cubic inches. If it was surface area, then it would have been squared. Okay, part A is done. I got the volume of the empty space. Let's now read part B. And again, I'll have to go ahead and fix on this slide. Make sure that was cubic inches, kind of important for volume. All right, part B, what does it want to know? If one bag of packing material holds 25 cubic inches of material, how many bags does Lee need to buy to fill the space around the candle? Okay, so as I mentioned earlier, when you send something in the mail in a box, you will normally surround it with some type of packaging material. So that way the item inside doesn't bounce around and get damaged. So that's what we're going to now find in part B. How many bags of packing material does Lee need to buy to fill the empty space that we just found in part A? So first things first, we need to take this answer from part A and start with it because that is the volume of the empty space. And now I need to do some kind of mathematical operation with the 25 cubic inches because one bag of packing material holds 25 cubic inches of material. And I'm trying to find how many bags. So what should I do? What would make sense? To get the number of bags, if each bag is 25 cubic inches, and I have a total of 160.826 cubic inches of empty space, what will I do with those numbers? Well, I'm not going to multiply. In fact, that would give me an answer that would be crazy high for bags of packing material. That wouldn't make any sense. But dividing would make sense. A classic division problem is figuring out how many items of a smaller size can fit into the total amount of size that you have. And that's what this problem wants us to do. If every bag is 25 cubic inches and we have a total of 160.826 cubic inches, how many of those little bags can fit into the total? So that is a classic division problem. Good thing you're using a calculator. Go ahead and do this now. If you divide, you will get 6.43304. So do I round up or do I round down? Well, you probably accidentally saw me revealing the answer. If I round down, then that's going to give me not enough packing material to fill the box. And the candle then might go back and forth too much and get a little damaged, possibly. So to fill up the entire space, what Lee's going to have to do is, even though she doesn't need 7 full bags, it's better to have more than enough than not enough in this specific situation. So that's why, even though 6.4, you would think you would round down because this is less than 0.5, it doesn't matter. This is not about normal rounding rules. This is about, does Lee need more than enough or less than enough in the situation? Well, it's better to have more than enough in this situation. That's why it's 7 bags. Okay, let's do one more problem together, and then you will do the problems on the next page on your own. Problem number 2, follow along, I'll read it out loud. Domingo built a toy box for his little brother that is 42 inches long, 21 inches wide, 24 inches tall. He has 1 quart of paint that covers 87 square feet. Does he have enough paint to cover the outside of the toy box with 2 coats of paint? Okay, what am I given? Well, I'm given the fact that I have a toy box. And you should know, boxes in real life are almost always rectangular prisms. And I got news for you. If it wouldn't be a rectangular prism, they would have told you in some type of words or in a diagram what type of prism it was. Since they never did, and they gave us a length and a width and a height, then we can assume this is a rectangular prism. What else are we given? We are given the fact that 1 quart of paint can cover 87 square feet. Okay, you might know why I just said that a little slow. Next question, what do I have to find? Does he have enough paint to cover the outside of the toy box? Are you catching one of the key words here? Square feet, the outside of the box, not filling up the inside? Well, this would be a surface area formula. And since it's a rectangular prism, I use the surface area formula of a rectangular prism. So this is how you take what you're given and what you're asked to find, and it will lead you to what you have to use to solve. One more thing I should point out. He wants to cover this with 2 coats of paint, not just 1. So I need to keep that in mind when I'm near the end of my work. All right, are you ready to go? There's something else that I need you to pay really close attention to details. Square feet. Did they give us the measurements in feet? Oh no, they gave us the measurements in inches. We're going to have to do a conversion. This was a little bit of a sneaky problem. And you might get something like this in the future. Spoiler alert for a problem on the next page. Pay attention to those details. We need the units of measure to be consistent. If it's square feet, then we need feet. So, do you remember how many inches are in a foot? It's 12. So we can take the length, divide by 12. We can take the width, divide by 12. We can take the height, divide by 12. We're going to have to do that to convert these inches into feet. So write that work down with me. Get your calculator ready. 42 divided by 12 will give us the length in feet, 3.5 feet. 21 divided by 12 will give me the width in feet, 1.75 feet. And then the height, 24 divided by 12. You should not need a calculator for that. Hopefully you already know that that is 2 feet. And now that I have my measurements in feet, now I can finally plug them in to the surface area formula. Because after all, eventually I have to deal with the fact that I'm trying to get 2 coats of paint, and the paint can does 87 square feet. Well, now I got everything in feet. Okay, are you ready? Let's substitute. 2 is 2, the length was 3.5, and the width was 1.75. Plus 2 is 2, the length is 3.5, the height, we got an h here, is 2. And then the 2WH. 2 is 2. The W was 1.75, and the H was 2. All right, I hope you're writing all of that down. Yes, I know the surface area formula of a rectangular prism has a lot of substitution. I know. It would probably help to do this piece by piece when you use your calculator. I mean, you could try to type the entire thing in at one shot if you want, but I'm going to do this piece separately, and then this piece separately, and then this piece separately, because order of operations, you multiply before you add. Here we go. This is going to give me 12.25 when I multiply these 3 numbers together. These 3 numbers multiplied gives me 14, and these 3 numbers multiplied gives me 7. Add them together, and I get a surface area of 33.25 square feet. All right, what am I supposed to find? Does he have enough paint to cover the outside with 2 coats of paint? The can do 87 square feet. So what am I going to do with the 87 and the fact that my surface area is 33.25? Well, kind of like you did on part B of number 1, it makes sense to divide. So that way I can find how many coats of paint can I actually get from the 87 square feet if 1 coat of paint will give me 33.25 square feet. So let's go ahead and do this. Divide in your calculator. That's going to give you 2.616, yada, yada, yada. So that's more than 2, isn't it? I need to make sure I get at least 2 coats of paint. Well, this is going to be enough for more than 2. So let's answer the question. Does he have enough paint to cover the outside with 2 coats? Well, yes. When we divided, we got an answer that was more than 2. So yes, he will have enough for 2 coats of paint. No problem. Write that down. All right, now that I've led you through 2 problem-solving situations, I hope you are now ready to do some problems on your own. Make sure you ask yourself the questions. What am I given? What am I asked to find? And then once you figure those things out, then you'll start to know what you're going to use to solve. Will it be volume? Will it be surface area? Feel free to use the first page of the guided notes and the boxes at the top to guide you through what you should do for each of these problems. So hit pause, do 3, 4, and 5 on your own, and then hit play once you're ready to see how you did. Okay, have you already done number 3, 4, and 5? If not, I need you to hit pause and do them on your own. All right, here I go. Did you notice on problem number 3 that we are talking about square feet and the fabric is covering the outside of the box? So that would be surface area, but before you use the surface area formula, did you notice once again that the surface area for the fabric is square feet, but yet they're giving you all the measurements in inches? This was kind of like problem number 2, wasn't it? So first things first, you should have converted the length, the width, and the height by dividing by 12 to change them into feet. If you did not do that, hit pause now, fix your work. And if you're thinking, well, Mr. Underkoffler, couldn't I just divide by 12 at the end? The answer is no. Square inches to square feet would not be going by 12. Square feet would be 12 times 12 to give you 144 square inches, making 1 square foot. And I bet you would have never thought of that. So this is why you really should do the conversion at the beginning. Okay, now I can go ahead and use my surface area formula. Again, if you did not already fix your work, I hope you hit pause and you're fixing it before you continue in this video. Here's what your substitution should look like. That should give you this step of work if you do the multiplication parts before you add, giving you a total surface area of only 4.5 square feet for each box. We need to find how many boxes can she cover if she has 100 square feet of fabric. So we're going to have to finish by dividing, and that's going to give you 22.2. Now, should I round up or should I round down to find the number of boxes she can cover? Well, you can't say 23 boxes. She only has enough for 22 and 2/9 more of a box. So it's only going to be 22 full boxes that she is going to be able to cover. Okay, problem number 4. We have a rectangular box and another rectangle. Did you notice this was actually 2 rectangular prisms? She is going to take the photo box shown in the diagram below, this guy right here, and she's going to mail it in a bigger box with the dimensions shown in this second sentence. So we're going to have to do the volume of the bigger box and the volume of the box, the photo box that we were shown, and eventually subtract them to find the volume of the space around the photo box. Kind of like problem number 1, part A. All right, using the dimensions in the second sentence. The bigger box has a volume of 656.25 cubic inches. The smaller box, if you use the dimensions from the drawing, will give you a volume of 186.2 cubic inches. If you subtract them, then you will be able to find the volume of the space around the photo box. Am I done? Let me revisit this question. Oh, no, I'm not done. If one bag of packing material holds 75 cubic inches, then how many bags does Sasha need to buy? This is kind of like part B now of problem number 1. We're going to have to take the volume of the empty space and divide by the volume that one bag of packing material will hold, which is 75 cubic inches. And that will give me the number of bags that I will need to buy to fill the empty space. Now, kind of like we talked about in number 1, part B, it's better to have more than enough than not enough in this type of situation where you're trying to fill up the box with packing material. So even though you divide and get 6.2673, you're going to have to round up to 7. Because if you go down, you're not going to have enough packing material. We need to have more than enough than not enough. And by the way, before I continue to number 5, if you need to see the rest of the work for number 4 or number 3, you know you can hit rewind on the video and pause wherever you need to. All right, finally, problem number 4. We are trying to fill up this corner raised bed vegetable garden in the corner of the backyard with soil. So filling up the figure would be volume. This is a triangular prism, which requires the volume formula area of the base times the prism's height. Before you can get area of the base, we need to identify what shape is the base. Well, it would be the triangle. And to get capital B, we need to do the area formula of that triangle. The lowercase b and the lowercase h are the measurements that will touch at the right angle. So that is the 6 and the 4. 1/2 times 6 times 4 is going to give you an area of 12. We can now substitute that in for capital B. But please do not think that the height of the triangle is the same as the height of the prism. It's not. These H's are not the same H's. I talked about this on problem number 1 with the candle. The H for the volume is the height of the prism, which goes between the two triangles. It's a very tiny little height of 1.5 feet. All right, multiply. You will get a volume for the raised bed of 18 cubic feet. Are we done? No. We need to find how many bags of soil that Zach needs to buy. Each bag fills 3/4 of a cubic foot, so 0.75 cubic feet. And we're trying to find how many of those 0.75 cubic feet will we need to get to fill up 18 cubic feet. Well, once again, this is a classic situation of a division problem. How many of these bags will fit into the total volume of the raised bed? So divide in your calculator, and it will be bigger than 18. If you divide by a number that is between 0 and 1, the answer will go higher, so don't be shocked by that. 24 bags. We didn't have to round at all. This ended up being a whole number. And that concludes our guided notes on problem solving with prisms. Thank you for watching. We'll see you next time.